Okay, so let's start with the another example, another exercise, correlation coefficient, and that is to be checked between two variables x and y. So let us first clear all these outputs which are there. So clearing this means that we are going to use this, and we have cleared everything. Now we can run it. So this is remark, nothing is going to happen. Next is given two series of objects with the same number of items. You can calculate the correlation with the help of the .CORR on one of them with the other as the first argument. So we can run this also, nothing will happen. Now we are going to import the pandas as PD, and in the x variable we are going to have the all those elements that is ranging between 10 and 20. So we run it and we get the all the data into x. To check it, we can just type x and run, and we can see that all these elements are available in the x variable. Right now we are going to have the another variable called y, and there we have given some values, and these values are the number of values should be same as in the x, so that should be kept in mind. And now we run this, so all these values are transferred into y. We can check this by writing y and then running it. So you can see that all these values which are here are available in the y variable. Now we are going to check the correlation. So correlation between x and y. So for that we have written the code as x.CORR within bracket y, and this is Pearson's method, which is depicted with small r. So when we run it, you will get the Pearson's correlation, that is 0.758640 and etc. Right? So this is how you get the Pearson's correlation. Now we also want to check whether this is x and y. Now we reverse it. So y dot code is same, only thing that we have reversed the y and x, or x and y. So we run it and you get the almost the same value, right? So that is how we can say that the Pearson's correlation is same whether you check it between x and y or y and x. Now the next is that you want to check with the Spearman's correlation also, and for that the method is same, only thing that we have to specify the method that we are going to use. By default it takes Pearson, but if you want to get the correlation of Spearman, then you have to mention it. So x.CORR y comma method is equal to Spearman, and then here we, of course this is a remark, but it is better to mention that what method you are going to use. So Spearman's row is RHO is the way that you can depict it, and you can run it. So once you run it, you get this value, that is 0.9757557 like that, right? Next, another method is there, that is known as candle, and there again we can get the correlation between x and y. So we have to, code is same, only thing that we have to change the method as candle. So method is equal to candle here, and this is just for our understanding, candles tau, and it is represented as TAU. So we can run this and you can get the another correlation 0.911111, that is the correlation between x and y using candle's method. Right? So all these are the three methods of getting the correlation. Now here you use .CORR to calculate all the three correlations and correlation coefficient, and you define the desired statistic. What is the method that you want to use it for, whether Pearson or Spearman or candle. These are all callable, we have called them, and then you get the results as it is shown here above. So that is how you can calculate your correlation coefficient between x and y, two different variables. Right? Thank you.